Now let's talk about some general research designs. Specifically, we'll talk about correlational designs and experimental designs. Let's start with correlational. Correlational designs measure how people score on two variables. For example, we might measure GPA and ACT scores. We might calculate a correlation coefficient between the two variables' scores. This correlation coefficient is known as R. R can range between -1 and +1. R's magnitude shows how much the scores on one variable can predict the other variable's scores, regardless of the sign. The sign indicates whether the relationship is positive or negative. If it's a positive relationship, this means that both variables move in the same direction. For example, as GPA increases, ACT scores also tend to increase. Or, as GPA scores decrease, ACT scores also tend to decrease. If the relationship is negative, this indicates that the two variables move in different directions. An example of a negative correlation might be the relationship between class absences and grade in the course. As class absences increase, grade in the course tends to decrease. One thing that's crucial to remember is that correlation does not imply causation. Correlation simply tells us the relationship between two variables. It does not tell us whether variable 1 causes variable 2. It does not tell us whether variable 2 causes variable 1. In fact, it could be that there is some causation between the two variables, but there could be a correlational relationship between two variables that's really due to a third variable. Let me give you an example here. This is an example of a correlational design where we're looking at this relationship between being smart and having friends. We see that there's a positive correlation between intelligence and the amount of friends that you have. So here, it's possible that being smart causes you to have more friends. Well, it's also possible that having more friends causes you to be smarter. Finally, it's possible that neither variable is caused by the other, but that both are caused by a third variable that was not measured in the study. For example, maybe parents who are warm and supportive tend to have children who are smart and also tend to have children who have more friends. When it comes to developmental research and really looking at change, which is what we're interested in development, we can use longitudinal designs, cross-sectional designs, or sequential designs. So these three types of designs are specific to developmental research. Let's talk about these in more detail, starting with longitudinal designs. In a longitudinal design, participants are studied repeatedly and changes are noted as they get older. This approach identifies common developmental patterns as well as individual differences. This design also permits examination of relationships between early and later events and behavior. So, one problem with longitudinal studies is that they're expensive and it's a big time commitment. Over time, participants might drop out of the study. Maybe they'll move away. If you're studying older adults, one particular problem that we have is that older adults might die. So this is one of the potential limitations of a longitudinal study. In addition, longitudinal studies, one of the benefits is that they allow us to examine continuity or discontinuity because we're testing the same people across time. One of the limitations here, though, is that participants might start to revise their responses. They might remember what they said before and then just say the same response because they can. Finally, participants, one of the biggest threats to a longitudinal design is cohort effects. So this would be where individuals born in the same time period are influenced by a particular set of historical and cultural conditions. Results based on one cohort may not apply to people developing at other times. The second type of design is cross-sectional design. This is where different groups of people are observed all at the same time. A cross-sectional design is a really efficient strategy for describing age-related trends and avoids such difficulties as participant dropout or practice effects. It's a really excellent way to measure age-related differences in development. For example, we might compare 10-year-olds to 20-year-olds to 30-year-olds in a cognitive task. So it's more time effective and it's less expensive. But it cannot address discontinuity or continuity because each age group involves different people. Cross-sectional studies also might suffer from cohort effects. These are problems here where differences between age groups or cohorts may result as easily from environmental events as from developmental processes. The final type of design is a sequential design. In sequential designs, investigators conduct several similar cross-sectional studies and longitudinal studies called sequences. The sequences might study participants over the same ages but in different years, or they might study participants over different ages but during the same year. So this allows for flexibility in collecting information multiple ways, and it also avoids the cohort effects of cross-sectional designs. For example, we might start with a cross-sectional study of 10-year-olds, 15-year-olds, 20-year-olds, and 25-year-olds, and measure each group longitudinally in 5-year intervals. Then we eventually have longitudinal data from all 4 age groups. So this is a picture that helps depict sequential designs. Here you could see maybe we start with a group of 8-month-olds in 1995, but we continue to track them for 5 years. But when we also add in another group of 8-month-olds in the year 2000, and we continue to track them for 5 years, as well as our now 5-year-olds for 5 more years. So here we're able to really uncover those cohort effects because it becomes clear whether the changes we're seeing are due to age. Is this group changing in the same way that this group changed? Is that the same as this change? So we can see whether it's due to age-related change or is it due to just the year, the sociocultural environment of that year. So I'd like to just have you guys do a quick self-quiz and just write down on a piece of paper what type of design you think the following examples are. A researcher is interested in how children of different ages process traumatic events such as school violence. The researcher recruits children in grades 3, 6, 9, and 12 for the study and interviews them about the mass shooting in Newtown, Connecticut. This is a cross-sectional design. How about this one? Age-related changes may be distorted because of biased sampling, participant dropout, practice effects, or cohort effects. This is a longitudinal design. How about this? It reveals cohort effects. It's a sequential design. A researcher is interested in whether frequent exposure to violent television in early childhood predicts aggressive and antisocial behavior in adulthood. This is a longitudinal design. It does not permit the study of individual developmental trends. Age differences may be distorted because of cohort effects. This is a cross-sectional design. The researcher is interested in age-related changes in adults' problem-solving skills. The researcher selects 3 samples, adults in their 30s, adults in their 50s, and adults in their 70s, and tracks them for 5 years. This is a sequential design.